Well, good afternoon, everybody, and welcome to today's webinar entitled Simplifying Your Large Assembly Process. My name is Rob Romanowski. I am the Director of Operations for 3HTI. I'm so glad that everybody could join us today on a lovely Friday. And with me today is Jonathan Conklin from PTC. So what we're going to do today is we're actually going to take a little bit of a closer look at a solution from PTC called the Advanced Assembly Extension that kind of partners up to PTC Creo. So just a quick housekeeping item. Everybody's going to be on mute throughout the webinar. If you have any questions, feel free to type them into the dashboard. We'll try to answer them as we go, but we will definitely answer all questions at the end. So one of the reasons why we wanted to review this today was I think when people hear large assembly or an advanced assembly extension, they think that, oh, well, we have to have thousands of parts to be able to utilize a solution like that, and that's not the truth. I mean, the truth is that you could have an assembly with just 50 parts and be absolutely disjointed. So what I did was I'm going to run through a handful of slides before turning everything over to Jonathan. But basically, the whole idea behind this extension is to help simplify your complex designs and allow for the development of advanced content with better control and system integration, and also being able to get other people to collaborate and see exactly what you're doing. So with our customers, what we've seen before they've had the advanced assembly extension, kind of manual. There's quite a bit of a manual process to support concurrent design and getting people on the same page, or being able to have two engineers work on the same design at the same time. More of a time-consuming process to enforce best practices and manage systems integration. And also an inability to securely protect and share company IP, which is becoming more and more critical in today's competitive market. Issues with top-down design. There were limited tools to define the assembly structure and enforce top-down design methodologies, and as well as poor communication of design criteria, resulting in assembly integration errors and rework. Also, issues concerning assembly configuration. There was a reliance on third-party tools and spreadsheets to define and manage these configurable products, as well as limited capabilities to design and manage component logic and assembly dependencies. And concerning performance management, limited tools to manage assembly's performance. Also, for process planning, am I reading ahead? No, I'm sorry. So I apologize. So some of the, I got lost there for a second. So anyway, some of the negative consequences concerning that our customers were, that these customers were facing, was difficulty to manage managing distributed design teams. So the design teams were not able to collaborate effectively or utilize concurrent engineering. There's also lost productivity due to that poor communication. There's a difficult process to implement and change due to assembly dependencies. There were delays in budget, loss of company IP, all these things. And I'm pretty sure that some of these has happened to all of you, and that's why you're sitting on the webinar today. So I think the good news is that we want to bring everybody to a desired state and help solve problems. We're not a peddler of software or 3D printing solutions or anything along those lines. What we do is we help customers solve problems. So we're helping people get to the desired state of where they want to be from a manufacturing standpoint. And with this particular solution, this helps to, with these specialized tools, help to manage concurrent design and development, implement predictable changes, modifying established and common reference geometry. You also have the much easier ability to copy geometry. You can drive predictable change propagation by editing established reference geometry. You can define read-only data and limit access utilizing this tool. And also you can define customizable products using spreadsheets, layout tables, and program applications. That's just a little bit of an overview of the current condition that some companies are in and the desired state that we brought them to. So right now what I'm going to do is I'm going to pass controls over to Jonathan. And Jonathan is going to give you a demonstration on the how this is done.
Yeah, that sounds great. Let me just see really quick. Which screen are you guys currently seeing? Are you seeing any screen?
Battle card screen.
Oh, so how do I switch? I apologize.
That's okay.
Let's see. I'm trying to switch the screen here.
Pause your screen share, and then go to show screen and.
Oh, okay, I see.
You should pick one or the other.
Okay.
I should take a survey to see how many people are using just one screen on their computers nowadays.
Okay, can you all see my PowerPoint slide now?
I see it now.
Okay, that sounds great. Sorry about that.
No
so,
worries.
Like Rob was saying, there's a lot of different use cases that customers could utilize Advanced Assembly Extension. And the Advanced Assembly Extension, it's a really interesting thing because, number one, a lot of people are designing in different design criteria, whether that's a top-down or bottom-up approach, and they may need to utilize some additional functionality that this can provide. In addition, some people may be even using Advanced Assembly Extension or have purchased Advanced Assembly Extension and may not be using it to its fullest capabilities. So what I basically want to talk to you guys about today is some of the challenges that customers are facing before using Advanced Assembly. Also, some of the capabilities, the highlighted capabilities of this extension. And then we'll dive right back into this the software here so you guys can kind of get your feet wet and see what it's all about. And then we'll jump into the value, what you guys can ultimately expect from utilizing this extension. So just to kind of give you an overview of what the Advanced Assembly Extension is, it basically provides you the tools required to speed assembly designs and streamlines the flow of information from design to manufacturing. So it's really creating an environment where you can create these really complex geometries or really complex assemblies while at the same time creating references to everything. So if you had to make any changes, any last-minute changes, or need to reuse parts, instead of assigning a few hours to do so, you can do this now very quickly. So some of the challenges here, if you're just doing basic assemblies, if you're doing 20 parts, that's relatively easy to assemble. It really doesn't matter if you do a top-down approach or a bottom-up approach. Either one is fine. But if you start to jump up the product number or the parts number, let's say like 200, it gets a bit tougher. It's not impossible to do, but some design intent is becoming more and more necessary. If you jump up to in the thousands, like John Deere, that's one of our main customers, they're creating assemblies that are 20,000 parts. And without utilizing the design intent of top-down design and utilizing things like advanced assembly, creating these assemblies could be just absolutely enormous and just a giant headache. So large assembly models, they can be really slow to retrieve and slow to work with as well. So I've heard customers who have pulled in their master reps and they're saying, yeah, we have to dedicate maybe half a day to an entire day just to have our model load in. And maybe they just have to load it in to make a small change. So waiting around for their assemblies to be retrieved, it's not a very efficient way to utilize engineers' time. And so companies recognize this, so they usually go and they say, okay, well, we need certain tools or we need some formal methodology to create this top-down design. So they usually go this route. If they specify different tools, that's another avenue they have to go down, another software they have to maintain. And then, again, trying to get all of your engineers to work on the same level of, hey, we're trying this new methodology of the top-down design process. Let's get everyone on the same page. How do you really enforce that? Again, just talking about changes again, changes if you're doing anything like late in the stage, that can be very costly and time consuming. If you're doing things like you just want to swap in and out a part, if you don't have references in place, in theory, swapping things in and out should be relatively simple, but once you actually get to your assembly, you may find just because of the way you designed it, it just doesn't work out, or it takes a really, really long time. And you also need to be able to protect your intellectual property. So let's say you have certain vendors who are actually taking care of swapping in and out parts, things like that. Instead of sending your entire data set to them, what you really want to do is just be able to send the bare minimum requirements so that they know if they put their part in, it'll still be referenced to certain things, but they don't have the concrete idea of what those things are. They just know the references. So that's really going to allow you to protect your intellectual property. And at the end of the day, you just want to do things faster. I mean, that's pretty much the bottom line. You know, I hear a ton of companies who are telling me, hey, you know, we work with Creo, we love it, or they're working with different CAD softwares, and they just want to be able to do this faster. They're missing deadlines. Their engineers are working overtime. And basically what the Advanced Assembly extension is going to do is solve all of these problems here. So let's jump into it. Let's take a look at some of the core capabilities. So the top-down design, I keep mentioning this, so let's actually go into this. This is basically a theory more than anything, and the theory is that you're basically looking at the top-level assembly first. So basically, you have the end result in your mind. So let's say it's a helicopter, a train, a car, I don't know, pick anything. You have that idea in the back of your mind, and then as you go through and you start to create this model, you start to create references off different geometries so that at the end of the day, if you need to make changes to that end result, you know that you already put the references in, you already did the legwork up front. So making that swap will be a lot easier. So with this top-down design, you could do things like part placement, geometry sharing. So if you just have the outline of, hey, I have this door panel, I have it referenced to this datum. If I need to swap this out or do any types of geometry sharing, I can do that. Also things like mechanism design. So you may have a pretty complex mechanism here, and at the end of the day, you know, you just say, okay, well, I don't care what the design is. If we go in like a month down the line and change this whole structure up, that's okay, because at the end of the day, we know it has to follow this path here. So just putting those ideas in place, and they may seem pretty elementary or, you know, I don't know, something like that in the beginning, but putting that legwork up in the beginning can save you a ton of time and help you out tremendously. So these are all kind of based around a couple of different things, and one of those things are the skeleton model, and this is a really special type of model. What it's basically going to do is it's going to contain all of your key design information, any type of references, any kind of design intent. They're going to be housed within the skeleton model. And the great thing about this is it's going to be located at the very top of your model tree based on like the assembly or subassembly, and it's not going to show up in any of your bill of materials. If you're doing any type of simulations, it's not going to show up in mass properties. Basically, it's just holding the information so that you can go ahead and drive things from it. So I keep talking about making references to different geometries, and there's a couple of ways you can do that. So we have this reference control, and that basically allows you to manage and limit component references. So you can see here I have this reference viewer, and what this reference viewer is going to do is basically say, okay, what are we looking at, number one, and number two, what is the relationship between that component and the other components around it? So you can see the parent and child relationship based on specific parts. And you can filter these references as well, so you can show either references or dependencies. You can say, okay, what's the scope? What do we want to look at? What's the status? Whether these are weak or strong references. And then you can also choose the reference type, so regular placement, relationship system, things like that. And then a couple of different options, like if it's going to be independent from the children, if you're going to exclude the children, suppress the children. So it really just gives you the ability to really control what you're looking at, so you can grab the correct references and see how they're related to each other. In addition to that, you can also go into the Creo parametric options, and you can further refine which references are going to be shown. So you can see here we have reference creation and backup control, and this is going to control like whether you have external components permitted. You could say either these are all components, some components, no components, things like that, just giving you greater control over your assembly creation. There's also things called inheritance models, and these are one-way associativity models. So you can think again like parent-child relationship. So let's take this model here. Let's say this is the parent, and you step through a design process. So you're making just small changes. Each of these changes are being seen within the children, but they're not going the opposite way up to the parent. You can also do things like interchange groups, and this is really great if you have a standard assembly that you utilize multiple times. So maybe you put the legwork in up front, and let's say you're working off, I don't know, a forklift. And say you're a company that deals with forklifts, but you have different models based off that. So you can have one generic one, set up a couple interchange groups. So anytime you have a request that says, okay, I need a forklift that has this seating arrangement or this length of the fork, instead of recreating the model, you can set up interchange groups that'll swap in and out these components. And it's able to do that because you set up these references on the fly really quickly, so it's going to save you a lot of work. You can also do things like merge and cut out, so you can see I have this specific geometry and a more complex geometry. We can merge these two and then cut them out so you can see the positive and negative areas here. Before we move into the value, let's actually take a look at the software here so you guys can get a better idea of how to utilize this extension. So let me pull that up for you and we'll get started with that. So we're going to work within Creo 3.0 today, and I'm just going to pull in an assembly, and this assembly is going to be a train. And so let's say we want to make additional changes to this train. You can see there's a lot of different sub-assemblies in there, and you can see on the screen we have selected the skeleton model, and that's holding all the design information in here. So if I go ahead and load this out, maybe I want to have multiple engineers working concurrently on this model at the same time. And this is one of the really powerful features within Advanced Assembly. You can publish certain geometries and skeleton models out to additional engineers so that they can work at the same time, and they can maybe work on subsections. And the great thing is you have these references set in place, so instead of them just building out things willy-nilly, they have some design intent in the back of their head. So let's say we have one engineer who's going to be working on the floor placement, something like chairs. They would need information like, okay, we need the envelope in which we're working in. We need the surface that is, designated as the floor. We need, I don't know, things like that. So now if you publish these out, they have this skeleton model or these references that says, okay, here's the parameters in which I can build. They build off of that, and then when everything is brought back together, you know everything works because you had set those references up in the first place. So let's actually see that in action. We'll have a couple of different, we'll have a scenario where there's a, a couple of different engineers working on different components. Some are working on the interior, some are working on the exterior, someone's working on, the front assembly where the wheels are housed. And you can see I'm all driving this off of some of my skeleton models, and also I can copy geometry. And so the copy geometry is a super powerful tool, and you get access through this through AAX. And what this allows you to do is copy certain geometries from, whether that's your entire assembly, subassembly, or a specific part. You can grab that, have that copy geometry within your subassembly, doesn't matter where it is, and work off of that. So the idea is you could have, let's say if you're working on this train here and it takes a couple hours to load in, instead of loading in the master rep, you can take a small subsection of it and then have, if you need to make references off of the copy geometry, you have access to that information even though it's not loaded into the screen. So I'm going to do things like copy the interior structure, or the structure, maybe the interior, things like that. You can see it's here. We have within the skeleton model some of that information that I was talking about. So again, I can just go ahead and grab some, interior information, things like that, and it'll show up within my model tree there. So if we move into a scenario where now all 4 engineers are working, you can see they're working concurrently, and instead of working on the entire model, they're working on subsections, but they still have that information that was copied before. So whether that's the copy geometry, the skeleton models, those published geometries, things like that. they have access to all of that, and they can work at their own pace, and they're not interrupting each other. They're all working concurrently, but they're all doing their own thing. And so you can see they're just utilizing, anything within Creo if they're doing any type of extrudes or revolves, patterning, things like that. Excuse me. They have that access as you would within Creo Parametric anyway. So this is really going to cut down on the amount of time it takes to create a model like this, instead of having, working in consecutively, like, okay, this guy needs to get this thing done first before I can move on. You can now have them work all together, and it really has this process streamlined. It's super efficient. It's probably the best way to go about doing any of this. And it's really going to allow you to create these assemblies without the additional rework, because everyone is they have that top-down design approach, so everyone knows what's going on. So if we go back to the main engineer, let's say the head engineer says, okay guys, I need all that information that you guys were working on. Let's go ahead and update. So that update is going to grab all the information that the other people have been working on. And you can see the interior, the exterior, that's now updating within this model. If there were any mistakes in the design, that's not a problem at all, because again, we've referenced everything. So you can see maybe there's a small bit of interference here. We can fix that very simply because we made those references. I can just go ahead and say, okay, I need to grab that distance measurement. And so let's say it's 350 millimeters. And then I associate that back to my model. And we can regenerate that and have it work. And that basically just fix up our interference. So instead of going back and doing a ton of rework, it's simply just, okay, I know your information. I can grab that information. Now I'm going to put it into whatever I need to fix. So super simple stuff, but again, super powerful as well. So again, if I needed to make additional features within this, let's say a pattern, since I already have those references, we know that they're going to fit. We know that there's not going to be any other interferences in place. We know that they're specified on a certain datum or a certain surface, so we know everything is going to work out. So it just makes life a lot easier whenever you're trying to build these types of things out. So I showed you the interior here. Let's take a look at the exterior and how the story kind of all comes together. You can see the other guy was working on the door frame, the windows, things like that. As we regenerate, you see these updates coming in. So in this instance, we have the door frame and also our wheel placement, things like that. Those are all coming into play here. And that's basically what the idea of AAX is. It gives engineers the ability to all work together with the same design intent in place. It gives you the ability to create these skeleton models that gives all the information of in terms of references and things like that. Gives you the ability to copy geometry and publish geometry so that your engineers can all work together. And ultimately, it's just going to speed the time to market within your assemblies. And it's an interesting one. A lot of people get kind of confused with this extension because traditionally extensions are housed within the applications tab. So things like flexible modeling or simulate, you actually have to go into a tab. But with what AAX does it basically gives you additional functionality within Creo Parametric. So let's jump back into our PowerPoint, and I can kind of show you some of the value that you can expect, kind of just hammer this home. So at the end of the day, you're going to be improving your performance. You're going to be able to do things much quicker and much more efficient. You're going to have less time dealing with the models, more time designing. You can make design changes with confidence. So if you ever have any what-if scenarios, you can take that leap of faith and be like, all right, yeah, let's test this out. Because at the end of the day, you know you have systems in place that are going to take care of you instead of hours of rework. It's going to enable efficient reuse. So if you have generic models in place, and like I said with the forklift example, you can do things like that and really speed up the process to get your products out to market. You can work collaboratively, internally and externally. So I showed you an example where it was more of an internal affair. You can also do things externally. So you just send out your skeleton models where it shows, just the references, and they can go ahead and have that work all set up for you. You're going to be able to have better quality parts. You can customize your products to your customer needs. It's going to be a lot faster than traditional methods. and it's going to cost your company a lot less than your competition because of the abilities that I showed you here today within AAX. So that's basically what the Advanced Assembly extension is in a nutshell. That concludes my presentation for today. If you guys have any questions, I'd love to answer them.
Excellent. Well, thank you, Jonathan. I thought that was very well done, very thorough, and very smooth.
Thank you.
Thank you. So what I'm going to do is, hang on. There we go. So if you want to contact us with any questions or for any additional information after the webinar, you can send us an email at info@3hti.com, or you can call us at 866-624-3HTI, which works out to be 624-3484. So Jonathan, I think you did a very outstanding job, like I said before, and there seems to be no questions in the queue at this time. So I think what we'll do is I will ask one of our other panelists if he is available, Mr. Jim Gilmore. I don't know if Jim's available right now, but I wanted to see if Jim had anything he wanted to add.
Yep.
Hey, Jim.
Hey, Rob. No, this just extends the ability of Creo and automates it to a higher level. All right. It's very difficult, if not impossible, to do top-down assembly and share geometry to different people and different groups if you're not using it. So that's what it does. My customers have great success with it, and you know, it's pretty unique to Creo as well. So. And again, I think some people need it that don't have it. They're building assemblies from the bottom up, piece by piece. They're not as robust or not as automated, and when they make changes, it's more difficult or it takes longer. And then people may have it, and they're only using some components of it, and they don't know everything else. So there's configuration capabilities in Creo. Like you said previously, most people think configurator is a dirty word, but you can create configurators in Creo using Visual Basic, Java, or with API calls in C++. That's about it.
So by the way, Jim Gilmore has, he's been with 3HTI since its inception 14 years ago, and he's also spent about 7 years with PTC. So he's been around a long time, has seen a lot, has done a lot, has worked with some really, really good customers that have some challenges, and he's helped them take their product development process to the next level. So one of the questions that just came in is, can the software output work with numeric machining? And what about feedback from real-world testing?
I'm assuming, yes, the Creo has built-in CNC capabilities, so you can do 3-axis contour surface milling with positioning. You can do 5-axis simultaneous manufacturing. You can do 4-axis turning, 4-axis wire EDM, and you can also do mill turn, lathe with live tooling. The second part of that question was what, Rob? I didn't really...
What about feedback from real-world testing?
I'm not sure what the quote-unquote testing refers to.
I think we need a little more clarification. If you want to clarify that question a little bit, we will answer it. Testing like heat distribution.
Heat distribution is thermal, yes. Creo has built-in FEA finite element analysis, so you can do thermal simulations and apply thermal loads and watch how it impacts parts and or assemblies.
Can it work with wood?
The FEA or the machining, absolutely, yes. We have customers running mills, lathes, and also routers to do wood tooling, to create wood products, Thomasville, furniture, Pella windows. So the answer is yes, it does work with wood, works with any material. The FEA, though, you would have to have the properties of the material to put in the FEA. So if you pick certain types of steel or plastics, et cetera, they're in the library. But in working with wood for FEA, you would have to have the properties of the material to give it the proper stresses and or deflections or breakpoints.
So I can actually add to that as well. Within Creo 4, we have a new library. It's the Standard Materials Grata design. And within that library, there's things like woods, plastics, foams, and stuff. So they're already pre-built within there, so you can actually utilize that within Simulator, things like that. But again, if you had more customized materials, of course, you could put your own, such as Young's modulus, things like that, Poisson's ratio, put that in there yourself and have them all set up.
Excellent. So next question, what other design software, even 2D software, can be utilized as an input?
Any. So Creo will take in DWG, DXF. There's also an upfront module of Creo. Creo is a bunch of apps that are put together that work in what's called an interoperable fashion. They don't just import or export, but they work together. So for example, there's something called Creo Layout. You can do, and it's 2D parametric 2D drafting. So if you do a layout in 2D and you can change that, someone, like Jonathan can build a 3D part or assembly or both off that design. And then if I update the the 2D layout, it updates Jonathan's assembly, and vice versa. He can also make changes in his assembly or part, and that will update the Creo layout drawing. But if you're working with old legacy data like AutoCAD or whatever, Creo also takes in any 3D solid format and can work with it. So you can open native CATIA, native Siemens NX, Unigraphics, SolidWorks, Solid Edge, Autodesk Inventor, Step, and IGES. Not only can you open them natively, but you can modify them. Okay, so or you can have a Creo assembly and bring all the aforementioned 3D CAD types into a Creo assembly in their native format and keep them as their native format. And if they update outside of the assembly, they will update in your assembly. All right, so wherever the change is made, the original CAD package or platform it's made, that will update automatically in your Creo assembly. If you want to go in then and modify those parts in Creo natively, you open them, but once you modify them, they are Creo native parts at that point.
Next question, do you need a special license for milling, or is this included with advanced assembly?
No, you need a special license for milling. There's three flavors. There's prismatic milling, which does your 3-axis, it does your 2D, 2.5D milling. It does your 3-axis contour milling with positioning, so you can do 5-axis. You can go and rotate in either direction. And then the step up then adds 4-axis wire EDM and 4-axis turning, and then the complete machining adds mill turn and 5-axis simultaneous to the base.
So two other questions. One question is, how often are the updates available? I'm guessing updates for Creo.
Creo comes out with a new release basically every 18 to 24 months. But between releases, there's updates that come out, new build codes every 1 to 2 months. So they might add new functionality, mid-release functionality, etc.
So there's another question concerning hardware requirements. So Richard, what I will do is I will email you a PDF form that basically says what the hardware requirements are concerning Creo. I think more importantly, and I know Jim, I'll let Jim talk to this a little more. I think what's important is the graphics card, which is really going to help your productivity. You don't want to buy, spend too much for a graphics card. You don't also want to spend too little and kind of hit some snags and roadblocks. But Jim, any other comments?
If you have an existing computer or workstation, you want a good graphics card, that's an open GL with I would say at least 1 gigabyte of RAM on the card. Let me step back. Creo will work with any computer with enough CPU or RAM to run it. But you're going to get the performance you want with an OpenGL card. There's specific cards for MCAD, whether they're NVIDIA or the other brands. But 1 gig to 2 gig is a really, really good card that you'll have for years, and enough RAM. 3D CAD likes RAM and video.
Next question is, how steep is the learning curve?
I would say that Creo is in one of the top 2 easiest to learn CAD platforms on the market today. We sell numerous CAD products here at 3HTI, and Creo, I would say, is the easiest because the user interface, when it went to Creo from Wildfire, the user interface is very similar to other mid-range, low-end, mid-range, and even high-end 3D CAD platforms. But Creo has all the robustness and automation that the other tools don't have. So relating to the previous question about CNC, if you change a part, your toolpaths update automatically. So if you've milled a part, your toolpaths upgrade automatically. You don't have to reprogram that part. You can also save your toolpaths off and apply them to new parts or new geometry. All right, so if you have milling or turning methodology for one part and you have a similar part, you can just save your toolpaths off in XML and just apply them to your new part, and the toolpaths will update using the same methodology, the same step, feed rate, feeds and speeds and all that, and machine the new part.
I think the other thing, we're actually going to have a webinar on this, not next Friday, but the following Friday, concerning what's called the direct modeling capabilities within Creo. So Creo is basically the granite kernel that Pro Engineer was built on, and also added to it the code from a direct modeling software called Co-Create, which gives designers the ability to create designs quickly. There's a couple of capabilities like freestyle and flexible modeling. Freestyle is more flexible modeling. Also, you can helps to create designs quickly. But what's really cool about flexible modeling is the ability to quickly defeature products downstream for analysis, and also when you make late-stage design changes, you can make them a lot quicker and easier than you can with most CAD systems. And actually, what's interesting is Creo files, as you all know, CAD files get larger as they go downstream, and Creo files are a third less in size than Autodesk and SolidWorks.
Yes, flexible modeling basically In Creo, you can do feature-based parametric modeling or flexible modeling, which is direct modeling. So you can just grab geometry and pull and tug on it and change it, and rounds, fillets, complex curves, they can intersect each other and you will not get a failure. So it's like having electronic silly putty. So as Rob said, you can have really, really complex models. I've seen very, very complex castings. Customers need to make changes, or FEA specialists need to simplify the model and get it ready for FEA. A lot of times they like to, you don't really need to defeature if you're doing your FEA in Creo, but a lot of times it makes your models more manageable and they run faster if you do defeature them. So, you know, it's like having electronic silly putty. Flexible modeling gives you the robust way to change any geometry, any surface, hole, radius, whatever. And that extends out into sheet metal design. It extends out into manufacturing, and it also extends out into tooling.
Another question is concerning international capabilities as far as converting metric into English.
Mm-hmm. It's just a configuration option. Yep. You can design in metric and English and just toggle back and forth between them.
Good stuff. Good questions. We have a very intelligent group out there, Jim and Jonathan. So I think at this time, this is going to conclude our webinar. I want to thank everybody for being on today. I want to thank Jim Gilmore for being one of our panelists, and Jonathan Conklin also for leading the demonstration for us today. And once again, I want to thank, most importantly, everybody for being on. And hopefully this was very informative and helpful. I will be posting this recording up onto YouTube and our website very soon. So by Monday, you will have an email from me so you can watch the recording. So once again, thank you very much, everybody, for being on today, and have a great weekend. Take care.